or the total length of time, not necessarily always years. It could be like months or whatever it is. It's just your total amount of time. Now, there's some words that go with the number of times each year. So some keywords that we need to know for N. So if I say quarterly, how many times a year would that be if we are compounding quarterly? You got it. If I say annually, once. What about semi-annually? Twice. What about monthly? It's just so T in all of these, if you don't look at it in terms of time, you could just, of years, you could just look at it in terms of time, like length of time, months, days, years, whatever it is. And daily would be, if we're talking about daily in a year, 365. So now there's your compound interest formula, and then there's continuously compounded interest. The difference between your compound interest versus continuously compounded interest is that for continuously, it's exactly what it says. It's continuously compounding that interest immediately on itself. So the way you would know which formula to use is in the word problem. It will literally say continuously compounded. That word continuously will be there. If that word continuously is not there, then it's the first formula. And so for continuously compounded interest, our formula is EA equals P times E raised to the RT power. So again, I know the exponent looks a little blurry, so it's A equals P times E raised to the RT power. I can't have side talk. It can't be every time I take a breath, I hear a bunch of side chatter. We just need to stick through the last class of the year. What's wrong, Stephen? What do you need that you keep looking at everybody? Okay, and the very last formula that you need to remember is the exponential decay or half-life formula. And again, I know it's a little bit blurry, so let's rewrite this. This is going to be N is equal to N sub 0 times 2 raised to the negative T over K power. So N is the amount of whatever substance we have at the end. N sub 0 is the amount of the substance we have to start with. T is our time. And K is the factor determining the half-life. So the factor that is basically decaying it.
For the last formula, is E just like E?
E is RE. Yep, that a 2 point whatever number that is. All right, let's get into some word problems. Like I said, it's all going as long as you know the formulas. I'm not trying to throw any tricks at you. So how long does it take $1,000 to amount to $1,500 if it is invested at 8% compounded quarterly? Because it didn't say continually compounded, right? It says compounded quarterly. We're going to use our normal compound interest formula. So it's going to be A is equal to P times 1 plus R over N raised to the NT power. All right, let's go over what all these variables mean again. What is A? The amount at the end of the period, exactly. What is P? The initial amount. What is R?
percentage.
The rate, exactly. What is N?
Number of times a year.
The number of times a year, exactly. And so this time it said compounded quarterly. So how many times a year? 4. So now let's plug in everything we know. How long does it take $1,000? That $1,000 is which variable? P, our initial amount. To amount to $1,500. Well, what is the 1,500? The A. If it is invested at 8% compounded quarterly, so we're going to have 1 plus. Now, do we all agree that it's 8%? Our rate is 8%, but I don't want to write the rate as a percent. I want to write it as a decimal. So how do I represent 8% as a decimal? 0.08, you got it. So my rate is going to be 0.08 compounded quarterly. So my N is 4. All raised to the 4. And then it says how long. So what are we solving for? T, our time. How long does it take? That's our time. And now we're just going to use our algebra skills to get our calculator ready form and to solve this. So now my first step is to do what, do you think? Divide by 1,000, exactly. So I'm going to go ahead, I'm going to divide by 1,000. So we are going to get 1.5 is equal to the quantity of 1 plus 0.08 over 4 raised to the 4t power. Now I need, because it's that whole quantity, that whole parenthesis raised to the 4t power, is now a good time to log both sides? Yep, it's a great time to log both sides. So I'm going to log left and log right. And when do I know what to use ln versus log? How would I know to use ln? Good. When your base is e, that's when we use ln. If the base is not e, then every other time we use log. And now I'm going to pull this 4t in the front. Do we all agree we're solving for t? Okay. So now for me to solve for t, I'm going to divide by the 4 and the whole quantity of 1 plus 0.08 over 4. So I'm going to get t is equal to, oops, don't want to do that. There we go. We're going, keeps moving on me every time I shift over. All right, we're going to get t is equal to log of 1.5. I get parenthesis happy. We all know this. Divided by, well, this is a must. You have to open your parentheses in the denominator. 4 times the log of 1 plus 0.08 over 4. If you wanted to add this in your calculator and simplify it, could you have? Yeah, I'm just leaving it like that because it really makes no difference to me. And now let me show you how we plug this into our calculator. What happened? I'm just going to my calculator. All right, so we have our parenthesis and our numerator. I think it was log of 1.5. And now I'm going to double close these parentheses just because I get parenthesis happy, divided by. Now, is this initial parenthesis in the denominator necessary? Absolutely. Yeah, the initial parenthesis in the denominator is absolutely necessary. And we're going to say 4 times. I don't believe that that times is necessary. I think if you just put 4 log, it would still work. I always just put the times. 4 times log of 1 plus 0.08 divided by 4. Double close. And we should get 5.119. And then we need to put our units. So originally the problem was saying what? How long? And how are we calculating this time? How long is what? Is it hours? Is it seconds? How long is what? Years. So we're going to say T is equal to 5.119 years. All right, next one. Find the amount of money earned if $100 is invested at 7% for 20 years compounded continuously. Because it has that word continuously, which formula are we using? The continuously compounded formula. So this time it's going to be A is equal to P times E raised to the RT power. So it says find the amount of money earned. So what are we solving for? A. We're solving for A. If $100 is invested, where are we subbing in that 100 for? P. So we know we're solving for A. So we're going to have 100 times E. And it says invested at a rate of 7%. How do I change that 7% to a decimal? 0.07. So 0.07 times T. Well, how many years are we compounding this for? 20. Guys, this is your calculator ready form. This is it right here. I'm going to show you how to plug this into your calculator. So let's go to our TI-84. Clear it. Now, E, I don't think we've ever used the E to an exponent before in the calculator. Maybe we have. You guys see where the ln button is? You see in blue right above it, it says e to the x. The way we get that blue is we press the second button and then press ln. So anything that's written in blue, the way to get it is you press that blue second button. So we're going to press the blue second button, and then we're going to have e to the x right there. Oh, sorry, what did I forget? Times the 100. That's fine. We'll do 100 times second e raised to the, I lost my spot, 0.07 times 20. All right, so this is what it looks like. Oh, I didn't put the parentheses in the front. I wonder if it's going to come up as an error or not. See? Nope, it still worked out. Okay, now on the whole entire test, I am going to ask you to round 3 decimal places. That's what I'm going to ask, 3 decimal places. But in this problem, what are we talking about? Money. Money. Do we ever have 3 decimal places for money? No. How many decimal places do we have for money? 2. So even if I tell you on the whole entire test, round 3 decimal places, if it's a word problem that involves money, do not do 3 decimal places. Only do 2. So what does this become? 405.52. But now let's be careful. Let's see what it's asking for. We want A, so our amount at the end is 405 times 52. Oh, sorry, 0.52. Sorry, not times 52, 0.52. So $405.52. But it didn't say what was your amount of money at the end. What did it ask? How much money was earned? Find the amount of money earned. So what do you think? I didn't earn all $405.52 because I started out with how much? $100. So what should I do? Subtract the 100.
Starting with this statistic every time I see a number without like those like like this. Everything is like big enough. You do it. Yesterday.
And you have to treat money like money. You need the dollar sign, okay? You need only 2 decimal places, not 3. You have to show me that you know this is money. Money, money, yes. If you wrote dollars, that's fine. All right, ready? Number 3. So it says a radioactive gas has a half-life of 3.8 days. How long will it take 1 gram of the gas to decay to 0.2 grams? Clearly, I'm not talking about interest anymore, right? So it's not one of the 2 interest formulas. What is this formula? The decay formula, the half-life formula. And so that is N is equal to N sub 0 times 2 raised to the negative T over K power. Okay, now let's go over what these variables represent. N sub 0, what is that? Your initial amount. Wait, N is your amount at the end of whatever the decay life is. And then T is our time. T is always time, right? And K is our half-life factor. So K is our half-life factor. So now let's plug in. A radioactive gas has a half-life of 3.8 days. Which variable is now 3.8? K is 3.8. How long will it take? What are we solving for when it says how long will it take? T. We don't know what T is. T is question mark. 1 gram of the gas to decay. So 1 gram is our what? Our initial amount. N sub 0 is 1. To decay 2.2 grams. What's the 0.2 grams? N. So now that we know all of this and we only have one unknown, we're going to plug in 0.2 is equal to 1 times 2 raised to the negative T over 3.8 power. Isn't 1 times anything just that, whatever it's multiplied, right? 1 times anything is just itself. Let's pretend this number wasn't 1. If this number was like 5, let's pretend this number was 5. Would I be able to multiply the 5 into 2? No, what would I have to do with that 5? Divide it over, exactly. But because it's 1, do I need to do anything with that? No. So we're going to go here. 2.2 is equal to 2 raised to the negative T over 3.8 power. Now I need to solve for T, but T is in the exponent. What do I do to get it out of the exponent? Log both sides. So we're going to have the log of 0.2 is equal to negative T over 3.8 log of 2. All right, I'm going to bring this all the way over here, rewrite it, and we're going to have the log of 0.2 is equal to negative T over 3.8 times the log of 2. I need to solve for T. So to start off with, I'm going to multiply by a negative 3.8 on both sides. So now we're going to have negative 3.8 times the log of 0.2 equals T times the log of 2. Now again, I have to still solve for T. So now I'm going to divide by the log of 2. So this is my calculator ready form, negative 3.8 log of 0.2 divided by the log of 2. Definitely need parentheses in the numerator. Probably wouldn't need parentheses in the denominator, but I put them just to be safe. And because this is talking about time, not money, how many decimal places am I going? 3. So T is going to equal approximately 8.823. What is this, years? Days, because the half-life factor was in days. All right, one more problem for today. One more problem forever. Stephen? Okay, let's type in. Let's go to our calculator. So in our calculator, we want to make sure that I always go parenthesis happy. We really need the parentheses in the numerator. So this is a negative 3.8 times the log of 0.2. So we need that initial parenthesis around that whole entire numerator, and then the double parenthesis to close it off at the end, divided by log of 2. I put the parentheses. I don't think we need it, though. Did anybody not put the parentheses in the denominator and get the same thing? And there it is. You found it?
Yeah.
Okay. Okay. Oh, never minus. Okay. So how about you guys try number 4 on your own? You got this. It's easier. Yep. I'll zoom in so you guys could see the wording if you don't have your computers up. That was the only science I liked. I hated physics. Physics was so hard for me. Chem was so easy.
Everything was basically.
Who needs another minute? All right, who thinks they have an answer? Rika, what'd you get? I got the same, 3.906 grams. Who needs to see me do this problem? All right, let's do it. All right, Stephen, obviously it's the half-life formula, right? So it says the half-life is 3.8 days. What does that 3.8 days represent? Which variable? Yeah. How much supply of 1,000 grams? What is this 1,000 grams? N sub 0 is 1,000. And when they say how much of the supply will remain, what are we trying to find? N. After 30.4 days, so do we agree that T is 30.4? Okay, so now we're going to plug in. So we're going to have, N is what we're solving for. N sub 0 is 1,000 times 2 raised to the negative 30.4 over 3.8. Guys, this is your calculator ready form. You're just going to plug in here. Stephen, do you need to see me plug into the calculator? You're okay. Does anybody need to see me plug into the calculator? No? So when you plug in, you should get N is equal to 3.906 grams. You do need your units, guys. In these word problems, you do need your units at the end. All right, so your homework